Welcome to another edition of Techbits. We really have a great one for you. Presidio Field CTO Eric Vogelpohl is going to take us through utilizing generative AI to analyze data using English as the coding language. It's going to generate the ETL code, and then we're going to run it through a private session utilizing Pandas AI. Now let's get started.
Hi, Eric Vogelpohl with Presidio. So in this demo, we're going to use OpenAI and LLM to help us reason over and analyze data, in this case, data from the Chicago data portal for Chicago crimes, using nothing more than English as our analytic language. But we're going to take a behind the scenes look with this code first notebook environment. So a couple objectives. First, most of us are familiar now with RAG, or the retrieval augmented generation of unstructured data. So asking LLMs to provide QA summarization and chat experiences for PDFs, FAQs, docs, etc. A common use case would be somebody working in a call center. Somebody calls up and says, we subsidize parking in this location. And that tool would then perform the necessary queries against all of your docs and FAQs that could potentially answer that question. LLM would read through them, reason a very nice, elegant answer, and tell the customer service agent, or yes or no, indeed, we do or don't provide that benefit. We know that's how LLMs work with unstructured data, but LLMs also have the ability to help us reason over and analyze structured data in data lakes, data warehouses, and CSVs, for example. It's sometimes called English as the new analytical language. And it's quite amazing. So I also wanted to hit two additional very important components about the roles of data catalogs and fake data or synthesized data. So in this case, I have a little bit of code that simulates what we would get from a data catalog. So the first is an example of our data's data type. So let's say, for example, we have a 10-column data table, and we have one column text format. But if we ask the LLM a general question, the may mistakenly infer that that column is perhaps something that it could aggregate. Of course, we would get an error when the tool attempted to run the code that the LLM wrote for us, because the LLM didn't have enough enrichment data about truly what that column is or what it does. So I'm going to provide the LLM the data type for those columns. In addition, I've written some fake data that represents just 3 real-world examples of what our true data set look like, so that when we send our fake data to the LLM, so help it reason over the context and nuance and understanding of our data, we're not actually exposing real company data. We're just exposing fake data that happens to look like our real company data. This tool happens to be called Pandas AI. But here's the fake data I created. I just created a data frame called fake data, and I provided it 3 dates for the column date and a bunch of basically made up examples of our data for all the others. Finally, the most important column being crime, I used real life examples. Notice that I called every example 2099, so that when we review the log, we indeed know it's sending just this fake data. Data catalog now have AI-powered capabilities to provide these field descriptions for you, so that these tools can get the necessary language and nuance and meaning for each column. I have synonymized the word incident with the word crime. So if your end users say how many incidents occurred on January 7th or how many crimes occurred, the LLM has enough nuance to answer that question. Okay, and then finally, ask a general question. Maybe this is all they see. What are the top 10 crimes committed so far in the year 2024? Pretty simple. And the only bit of code necessary, if you will, is just to, from this data frame, invoke the function that passes my query to the LLM to begin the code generation. The tool, in this case, Pandas AI, running on my computer, will run that code, present the answer, and then finally we'll take a look at the code itself that was generated by the LLM. The LLM passed that code back to me. My computer ran it on all 50,000 rows in my data set and provided the answer. Again, I want to stress that the LLM is not getting your data. What it's getting is the schema and examples of your data plus the prompt, and it's generating the code necessary for your computer to run. So let's hit play and see this work. And now you can see it's working. So you can see the asterisk. It's working on that next question. What are the 10? And it's dutifully provided the answer. Notice it went above and beyond. It even provided the count. I didn't ask it to do that, but it provided the count of all of these crimes committed this year. Finally, this last cell told it to print the last code generated, and you displayed the results in a nice table for me. Super simple. Now, let's go behind the scenes. I asked the tool to produce a log file. We're going to take a look at that log file, and we're, of course, to ask the first question that we asked. And the tool itself used my prompt, and it prefixed the information from our catalog. And you can see, sure enough, here are my fake data examples along with the description. That provides the LLM the necessary context to the question. It now knows everything it needs to know about the 50,000 rows in our data with only seeing the first fake 3. The tool told it to produce the Python code. It's the code here. So that's an instruction to the LLM to perform that function. And finally, the LLM took all of that information and asked me this question. I'm going to provide you the code. And sure enough, right here is the code necessary to perform that function. It even provided the necessary inline comments. It says here I'm filtering the data for 2024, then I'm counting the occurrence, then I'm getting the top 10, and then sure enough, there's the result. And that's what provided the result you see here. Now, let's take a look at another question. What if plot is a line chart, the daily trend of the crime for all days available? The LLM knows the pandas code in this case, or if we wanted to use SQL, we could use SQL. And everything that was returned was run on my computer over those 50,000 rows. And we have everything we need to produce this line chart. If I rerun this command, we can see that the LLM provided the code necessary to produce this.
Thanks, Eric. That was a great demonstration on how you can utilize LLMs to reason over your data by just asking questions in English. Now, as a quick review of what we saw, first, we grabbed data from a structured source, in this case, a CSV file. Second, we were able to take the columns and generate synthetic data in the form of 3 dummy rows. Next, we sent the LLM, in this case, OpenAI's ChatGPT-4, and then asked it to provide the data types. Once we retrieved that, we reviewed and updated with any corrections needed. We then asked the model to generate the ETL code. Now, in our private session of Pandas AI, we ran the code with questions about data where we were able to retrieve the results in various formats that we asked for. Pretty compelling. So that does it for this episode of Techbits. Tune in next time for more insights.